Hi everyone, my name is Mia. Today I will introduce our project on predicting the house price in Ames, Iowa. Housing is usually the largest asset in a family owns, so even small price errors can make a big financial losses for buyers, sellers, and lenders. Prior work in real estate economies uses hedonic price models and multiple linear regression to link housing characteristics to price, and meta-analysis show that structural figures such as size, quality, age, and are consistently important drivers of value. The question is, how do structural characteristics such as size, age, building type, and amenities affect the sale price on a house in Ames, Iowa? To answer this, we use multiple linear regression model and interpret estimate coefficients, confidence intervals, and the prediction performance on the test sets. Our data come from the Ames Housing R package, which includes 2,930 residential properties and 82 variables recorded by the Ames City Assessor's Office. These administrative records are collected routinely for property taxation, so the measurements of sale price and the key structural figures are systematic and highly reliable. Comments due to the space limitations on the poster, despite the code being quite excellent, not all results could be fully present on the poster.
This part is a discussion about the method. First, we divide the data into train and test sets in a half-a-half. And then use the train set to build the MLR model. Referring to the paper, our raw model is a model with 10 variables, including an interaction variable, to observe the impact of area and house prices in different build types. At the same time, we use auto selection to initially simplify the raw model with the direction set as both, and we compare it with the final model in the end. The flow chart is on the left. By drawing the residual plot and testing for VIF, we found that the raw model violated the assumption of constant variance and linearity, as well as having some multilinearity variables. We first removed the multilinearity variables from the raw model to obtain model 1, and then perform variance stabilization transformation and box cause transformation to address the issue of violating the assumptions. We obtained model 2 and model 3. Subsequently, we use ANOVA to delete the insignificant variables, resulting in model 4 and model 5. By examining the adjusted R-square and AIC, model 5 performed very well. However, we can further simplify. Based on model 5, we removed two variables with VIF value greater than 3, and the performance of the model was almost unaffected. The final model is much simpler and still has great predictive power. We conducted a unified test on all the models, including the automatically selected model, the final model, which was comprehensively adjusted R square, AIC, BIC, AICC, and the number of variables. Performs the best. To ensure its validity, we then plotted the residual plot for y and for each x, and QQ plot again, and all didn't violate the assumptions. For results, we began to use the test data to test the model. Compared with the model fitted by train, the MSE, RMSE, and R square are very similar, which indicates that our model has good interpretability. Moreover, the MSE and RMSE are very small. The error in predicting the price is approximately 1.18 times, and the R square value is not particularly large, which indicates that there's no overfitting. Then we studied three specific type of points, namely leverage point, outlier, and influential points. Compared with final model and the raw model, the conclusion is that although the number of the three types of outliers is approximately the same, they have indeed decreased overall. In fact, by correctly transforming the raw model, even if the number of outliers is approximately the same, the problem is not significant. The final step is to plot and compare the residual distribution of the train and test datasets under the final model. Since validation is not performed, training and the nodes to approach the function y equal to x. And we also test C1 and the C2. This time we compare the final model with the automatically selected model. The performance of the final model is still better.
Hi, my name is Zhao Du. In our project, we use an automatic selection to explore and candidate models and then choose a final model manually using diagnostics and interpretability. Model 2 ethics emphasizes that whether a method is ethics depends on foreseeable and avoidable harms. All of our predictors do not contain any personal and sensitive information about individual owners or residents because data do not involve private attribute, automated and manual selection are ethically equivalent in this context. In our final model, the main structure predictor that remain significant are these predictors, and you can see them on the poster. In general, larger houses with bigger basement and the garages, more fireplaces, and more masonry linear seal for more. Even after we control for all the other variables in the model, we also find other houses sell for less. Uh, the interaction terms show that the effect of living area is not the same for every building type. Finally, there are also a couple of important limitations. First, data comes from a single area, so we should be very careful about generalizing this result to very different housing market. Second, a small number of houses have unusually low prices, leading to large negative residuals and some influential point. That's all for our poster and presentations. Thank you very much.